Imagine a world where the sun rises, hangs motionless in the sky, and then turns back to set in the same direction from which it rose. A world where the ground at noon is so hot it could melt lead, and by midnight, it's so cold that ancient ice billions of years old lies frozen there. A world whose heart is so big science can't explain it, and the entire planet is shrinking, its very skin cracking apart. For decades, scientists ignored this planet, dismissed it as a simple, dead rock. They were catastrophically wrong. This is no ordinary world. It is our solar system's greatest deception, its deepest secret, its most dangerous truth. Welcome to Mercury, the planet you don't know and will never forget once you do. Imagine a world where the laws of physics seem to break, where the sun rises in the east, climbs toward noon, and then suddenly stops. Before an observer on the ground, if they could survive, it then reverses course and sets back in the same eastern horizon from which it rose. Darkness falls, only for the same sun to rise again moments later, this time committed to its journey across the sky. This is not science fiction. This is the truth in our own solar system, on Mercury. The secret of this impossible event lies in Mercury's bizarre dance, the remarkable 3-2 spin-orbit resonance. Mercury orbits the Sun every 88 Earth days, but rotates on its axis once every 59 Earth days. But it's not just that. Mercury's orbit is elliptical. When it swings closest to the Sun, its orbital speed briefly exceeds its rotational speed. At that precise moment, an observer would see the Sun move backward, not an illusion, but the pure mathematics of motion. Ancient myths told tales of the Sun reversing course. On Mercury, it's a daily reality. On Earth, a 20 degrees Celsius day-night difference bothers us. Now, imagine a world where that difference is 610 degrees Celsius, where midday heat can liquefy metals, and the very next night, that same ground plunges to negative 180 degrees Celsius, colder than any place on Earth. This is thermal violence. The cause is a brutal lack of atmosphere. With no blanket of air to moderate temperatures, the surface is exposed directly to the void. It bakes under unfiltered solar radiation by day and radiates all its heat into the cold vacuum by night. This isn't weather, it's a daily atrocity that defines the planet, turning rock to dust and challenging the limits of human engineering. Yet here lies the ultimate cosmic contradiction. On this scorching world, at its north and south poles, inside deep craters where sunlight has never reached, temperatures plummet to negative 200 degrees Celsius, and there, hidden in perpetual shadow, radar and spacecraft have found vast reservoirs of water ice, hundreds of billions of kilograms of it. This ice arrived from comets and asteroids that struck Mercury eons ago. A tiny fraction of the liberated water molecules randomly bounced into these polar traps and froze, preserved for billions of years as a frozen time capsule. More astonishingly, this ice is often covered by a dark blanket of complex organic compounds, the very building blocks of life. This discovery shatters the simple division between habitable and uninhabitable worlds. It tells us that even a hellish planet can harbor a frozen sanctuary, and that the water in Earth's oceans likely arrived the same way. Now, picture a peach. For Earth, the pit, the core, takes up about 55% of the radius. For Mercury, that pit is so enormous it leaves only a 17% sliver of fruit, the rocky crust and mantle. Mercury's iron core makes up a staggering 83% of its radius. It is a massive, hot iron ball wrapped in a thin, rocky shell. This density is a colossal puzzle, a blow to all standard models of planetary formation. How did it get so much metal? 3 catastrophic theories compete. A giant impact early in the solar system might have blasted away most of the rocky mantle, leaving the dense core behind. Or the searing heat of the young sun could have vaporized the lighter surface rocks before Mercury fully formed, leaving it metal-rich by birth. Or perhaps it simply formed from different, iron-enriched material. The Messenger mission gave us data that challenges each theory. The mystery remains. Mercury is a lingering question, forcing us to rethink how worlds are born. And this world is dying. Mercury is shrinking. Scientists estimate its radius has contracted by up to 14 kilometers since its formation. As its massive iron core slowly cools, it contracts. The rigid outer crust cannot shrink smoothly, so it buckles, cracks, and fractures. This has created planet-spanning cliffs called lobate scarps, some 500 kilometers long and 2 kilometers high, towering walls of rock as if the planet is wrinkling like a drying fruit. The most startling fact, this process may still be active today. Some scarps look fresh and crisp, suggesting Mercury isn't a frozen museum from the past, but a living, breathing world still changing, still dying. It teaches us that death is not an event, but a visible, ongoing process. Yet within this small, cooling, shrinking world beats an impossible heart. Mercury has a global magnetic field. For a planet its size, this shouldn't exist. Small planets cool quickly. Their cores should solidify, killing the magnetodynamo billions of years ago, as happened on Mars. So how does Mercury's heart still beat? The answer reads like a thriller. Perhaps light elements like sulfur act as an antifreeze in its core, keeping part of it liquid. Or maybe the gravitational tug of the sun on Mercury's elliptical orbit constantly flexes its interior, generating heat through friction, like bending a wire. Or perhaps an exotic, unknown mechanism, a planetary-scale thermocouple, is at work. Messenger even found this magnetic field is lopsided, stronger in the north than the south. Mercury shows us that physics doesn't end where life cannot exist. Bepi Colombo, arriving in 2025, seeks to solve this mystery of the beating heart. The surface bears the scars of a trauma that nearly destroyed it. The Caloris Basin is a 1,550-kilometer-wide planetary wound, larger than the distance from Los Angeles to Denver. The impact that created it, nearly 4 billion years ago, released energy equivalent to billions of nuclear bombs. The shock waves traveled through the entire small planet and focused on the exact opposite side, shattering the crust into a chaotic jumble called the weird terrain. It's as if Mercury suffered a planetary heart attack. It survived, but barely. Caloris is a permanent reminder that the early solar system was a violent battlefield, and Mercury is a living witness. This planet's orbit holds one final, profound secret. In the 19th century, astronomers detected a tiny, unexplained wobble in Mercury's path. Its perihelion was advancing 43 arcseconds per century, faster than Newton's gravity could explain. For decades, they searched for a hidden inner planet, Vulcan, to account for it. They never found it. In 1915, a young patent clerk named Albert Einstein had the answer. His general theory of relativity described gravity not as a force, but as the curvature of space-time by mass. When he applied his equations to Mercury's orbit, they predicted an extra precession of exactly 43 arcseconds per century, a perfect match. Mercury, without knowing it, had provided the first experimental proof for a theory that revolutionized our understanding of the universe. That small error in its path validated Einstein and opened the door to modern cosmology. So this is the story of Mercury, a story of a world of impossible extremes. It is not just the closest rock to the sun, it is a lesson, a warning, an open question. It taught us that nothing in the universe is as simple as it looks, that a hot world can hide cold ice, that a dying world can host a beating heart, and that a small mistake in a planet's path can rewrite the textbooks of physics. Mercury is still out there, whirling in its strange, fast orbit around the sun, shrinking under the stress of new cracks, holding ancient secrets in its dark polar vaults. It is waiting for us, waiting for our curiosity, waiting for our questions, because Mercury isn't just a planet, it is a mirror. It shows us that nature's creativity has no limits. It shows us how much lies beyond our current understanding. And it shows us that when we dismiss something as boring or ordinary, we might just let the universe's greatest marvel pass right before our eyes. So next time you look up at the night sky, glance toward the brilliant sun, and remember, closest to it, a small iron world is still writing new chapters for us all. The planet you never thought about is the one changing everything. Mercury, the most extreme and most enigmatic neighbor in the cosmos.